reactions of anhydrides. So acid anhydrides are the ones in the middle, right here. So they're not as reactive as the acid chlorides, but they are more reactive than the esters, the carboxylic acids, and the amides. So let's look at what reactions can happen and can't happen. So the first reaction is that having Cl minus as a nucleophile. So the mechanism, if we were to draw the lone pairs on Cl minus, go like this. Or let's actually just keep it more consistent. We'll just go right there. And this is going to be a big molecule. So make sure you have enough space here. So you have the CO minus. Cl now is attached right there. And then, of course, you have the O, CH3. Now, when those electrons on the carbonyl oxygen, where you broke the pi bond, are going to come down, then something has to leave. And then you're going to ask yourself, what's going to leave? What's the better leaving group? Once again, this is the best leaving group. So it will be kicked out. And guess what? You're back at the anhydride. So that's why this reaction doesn't take place. However, other reactions take place, such as making carboxylic acid out of an anhydride. Why? Well, because we add water, it can become an OH, and that makes it a carboxylic acid. So let's take a look at the mechanism for the next one. Let me just bring that down. Just put a lone pair here. Okay, I'm just going to draw an arrow here. Out. Now, what's going to happen is similar to what happened above. So here's water added. Oh, this one jumped up. Here, I'll just draw water here. So again, water is added. Now, of course, it has to be deprotonated. So you have another water molecule. We'll deprotonate. And then Okay, and then you have this right here. And OH. And the question then is, what's the better leaving group? Is it the OH or the OCOR? And the answer is, this is the better leaving group. So then these electrons come down and that's kicked out and you're making the carboxylic acid. Plus what's left over here is you have the OCOR minus, which can be protonated from the acid that's going to be generated from here. And then finally, yes, you can replace it with an amide to make an amide out of the anhydride. Once again, you need two equivalents of this, and the product will be, it's a similar mechanism, will be NH2 as an amide that was added plus NH4 plus OCOR minus. So again, it can be made because NH2 is a worse leaving group. So an amide is less reactive than an acid anhydride. Therefore, the reaction will take place.